Hello, and welcome to Ubuntu AI podcast. I'm Andrea, and together with Maciek, we will be your hosts. From fun experiments to enterprise projects, AI became the center of attention when it comes to innovation, digital transformation, and optimization.
Open source technologies democratize access to state-of-the-art machine learning tools and open doors for everyone ready to embark on their AI journey. Ubuntu AI will be your guide in the industry where a community of like-minded people meet to make an impact. Welcome to the next one. Today we have a very special guest. Pedro from Spectrocloud is with us. We met at KubeCon and we had tons of super interesting conversation, and his knowledge of Kubernetes is far above mine, and we wanted him to share additional insights and cool things for you guys. So Pedro, welcome and happy to have you here.
Thank you, Maciek. Thank you, Andrea. This is my pleasure being with you guys here, and obviously it was awesome meeting you at KubeCon, and like you said, having some very good conversations about how AI is impacting the world of Kubernetes and how it's actually accelerating a lot of the different technologies that we see being now put together in the community, getting behind it as well. Yeah, thank you for having me.
Before we get started, and for those who are not familiar with it, Pedro, what is Spectrocloud doing? And what does it have to do with AI?
Very good question. So Spectrocloud has a product called Palette, and Palette itself is a Kubernetes orchestrator platform. And Palette focuses on essentially building, developing, managing your Kubernetes at scale. So it's not only about AI, but obviously Kubernetes and Kubernetes workloads. So that's what Palette and Spectrocloud focuses on, how to deliver Kubernetes at scale, essentially anywhere. So private clouds, public clouds, and at the edge as well. And to your point, how does it all related to AI? It's a very interesting question because I think at KubeCon, and Maciek will help me out here, I think everything was about AI this year. And I think there's a big focus on how to move all of these different AI workloads onto Kubernetes. So obviously, as a Kubernetes orchestrated platform, now Palette is focusing a lot on how we can also better enable deploying AI workloads onto Kubernetes clusters as well. So hopefully that gives a better idea.
My initial joke was that all Kubernetes workloads are nowadays on AI, but you might disagree with me. But should I assume then that together with Maciek at KubeCon, you talked a lot about GPU resources and how Kubernetes can help them or not, depending on how it is used? It's a question for actually both of you.
So basically, we had a very fun conversation because my main goal of using Palette and also talking to Pedro is to stop worrying about it, because from a data scientist perspective, I just want to train my models or run my inference endpoints and don't really care about like how this all is managed underneath, right? Obviously, we have to care, especially now when we are in like initial development phase, but there is a lot of hassle in actually even on a single Kubernetes cluster and a single worker node to get access to the GPU and share it with other people, because obviously you are not getting a 10,000 GPU cluster just for yourself. It would be cool, and then we would not need Pedro at all. But unfortunately, the resources, that will be a bit expensive. So we are sharing these resources with multiple people, and that's where the whole GPU management is super interesting. But Pedro, can you tell us from your perspective, how does it look? Because you must be flooded by tons of people from my world doing AI stuff and coming to you and, hey, we want to run it on Kubernetes, we need GPUs, we need MIC, we need GPUs on multiple clusters, we need networks between them and all the weird stuff. Is it something that you had already for a long time in Kubernetes? Is it something that you are working on? Or like, what's the general feeling from your side, being like a DevSecOps person, not an ML background person?
Yeah, no, that's very interesting. I think there's a few sides. There's a few sides to that question. I think so. The first one is obviously we see an uptick on people that want to use, like I said before, AI workloads onto Kubernetes, and that's being driven, as you said, by the ML scientists, the ML engineers. They don't really care about the platform, or they don't really care about the infrastructure. But because they're the ones driving all of these requirements, we see this shift left into Kubernetes now, where all of these ML engineers now have to worry about how they run their Kubernetes platforms, how do they run their Kubernetes deployments, and they have to worry about things like that you just said, like MIG and network and storage, and they don't want to care about any of this. Like you said, they just want to deploy their pipelines, they want to deploy their applications, they want to run them, to test them, and they don't really want to care about what's running underneath. So obviously in the past couple of years or so, we've seen a massive uptick, and AI is being thrown left, right, and center, both from the data center perspective, where you will have, or you could have, basically almost infinite amount of resources, like you said, thousands of GPUs, a lot of network bandwidth, storage, etc. But also even at the edge and doing inferencing at the edge, how do you manage all of that? So we see a massive uptick there. And I think from my perspective, especially at KubeCon as well, it's interesting to see that there's a lot of people now having a discussion about running Kubernetes on bare metal as well, right? So, and I think AI is a big contributor on that as well. So people trying to understand how can they do that, and if they want to use Kubernetes to do that, how can they run it at scale on bare metal? Because to your point, if you're running one server with a couple of GPUs, it's one thing. But if you're running 100 or 200 with a few thousand GPUs and perhaps 100 clusters distributed between them, then how do you do that, right? So I think that's the main concerns that we hear from the industry.
Maybe a bit of an unpopular opinion, but do you think that when it comes to AI, there is also a bit of a concern around the lack of knowledge by people who work in the AI space? I remember at some point I was reading some studies that Kate is intimidating for data scientists, machine learning engineers. I know Maciek has a lot of data science experience, and he also knows Kubernetes, but not everyone is Maciek. Do you see that, Pedro, as well?
We should put that on a t-shirt. Not everyone is Maciek. I would probably wear that. Yeah, no, I absolutely see that. And to your point, being a good data scientist and good at Kubernetes is like 1% or maybe less than 1% of the population out there. It's really hard to find people that have those amount of skills, right? So actually, to your point, like skill shortage, which is I guess what you're alluding to, is a big factor out there, and actually one that we tend to focus on and have a discussion about with most of our customers is how can you enable the current workforce that you have, which could be ML scientists or it could be infrastructure people, to be able to not only deploy Kubernetes clusters, but also deploy some of these workloads, or at least have some separation of duties between them, right? So you can have your platform engineering teams just building all the different platforms for deploying Kubernetes clusters that are going to run AI workloads, and then you have your ML engineers, your Macieks as well, that will then deploy all the different workloads on top of that. But then how do you service all of this? And I think it's building this at scale and packaging all of this up is where the challenge is. And I think that's where the intimidation comes from. So it's not about building one cluster in one server where maybe a handful of people will be able to play with. The challenge really comes when you have a team of 100, maybe 150 people that have to access those resources. And you start talking about role-based access control rules, data leakage, and all of that kind of stuff. People having the right access at the right time to the right things. So that's when these problems become bigger and bigger. But I'm sure Maciek has more on that too.
No, but to make it useful for our audience, because I want to pick a little bit on your experience. So if I'm an ML professional, I got access to big Kubernetes infra from my company, which was generous enough to give me some privileges to play with the resources. There are GPUs there and so on. Where do I start? What do I start reading? How do I start learning? Or maybe how do I start jumping into the ocean and start using it? Like, what would be the guidance for a beginner who is like seasoned data professional ML engineer, but has no clue about K8s and got presented with one?
That's a very good question. There's a few points, and to your point, I think to what Andrea was saying earlier, that's when it becomes overwhelming, and they're like, "Oh, wait, we have so many things to worry about," because K8s will touch a bunch of different parts of your infrastructure. Storage being one, networking being another one, compute. So how do you get all of these things together? So, for example, from a data science perspective, there's a few things that you probably should start to learn or understand. So, for example, how does Kubernetes deal with storage, right? Because that might be something that you'll have to go and work with because that could affect your performance. Then the other one is around notebooks, for example. So if you're deploying your notebooks, and if you need especially certain kinds of ingress or role-based access control rules for your notebooks, how do you play with this? What kind of Kubernetes technologies can you add onto your clusters to manage, for example, your notebooks access? So I think all of these different things will be, I would say, 101. So how does Kubernetes do storage? How does Kubernetes do networking? So then you can start pairing that up with your knowledge around data science. And then you'll get deeper into the different, we call them Kubernetes operators, for things like how do you utilize your GPUs? And you get into, for example, the NVIDIA GPU operators, the NVIDIA network operators as well. So then how do you deploy these in your different servers? And this could be heterogeneous or homogeneous, right? So it could be all the same. 100 servers could be 100 different ones. And how do you then deploy all of these different operators and all of these different components in a way that it's exactly the same every time you deploy a cluster and every time you manage a cluster? So I think there's a phased approach answering your question. So I think the 101 is obviously trying to learn the different Kubernetes concepts. I think for AI specifically, storage and networking is the most important because of mostly performance, I would say. And then as you scale that up, you need to start to understand about the GPU operators of the world, the network operators of the world. And then if you go get yourself into this multi-cluster management side of things, then you'll have to start to understand, okay, how do I schedule all these different jobs into all these different clusters so I maximize my GPU or my infrastructure utilization? And I think that's the advanced level. That's the magic level if we put it out there. And for that, I would also recommend people to go and watch your KubeCon talk. I've watched it myself actually this week. It was very good talk, man. Very good talk. I recommend anyone to go and watch it. It's very insightful.
Thanks, Pedro. But also, I think that while you are talking at this, I made one realization. Andrea, isn't this why you guys created Kubeflow actually, to make it easier, and instead of even going to level 1 that Pedro mentioned in the beginning, to go to level 0 and basically like hide Pedro and his toys in the basement and give you just a nice UI to play with Kubernetes? Isn't that what you guys are doing?
I'm afraid that if I say yes now, Pedro is going to drop this podcast.
Yeah, I lose my reception at the basement there.
No, I yes and no, Maciek. I think that what we did was to add a layer on top of Pedro's work, especially for data scientists who don't have experience with Kubernetes. At the same time, I think that as you scale and grow your AI initiatives within an organization, it's impossible to keep avoiding Kubernetes. But it's also the moment when you should have a better structure of your teams. Not all data scientists should tinker with Kubernetes, and then you should start having MLOps engineers and ML engineers, and they should do very different things. And I think that's where having someone who looks at Kubernetes makes sense. But in the early stages, I think it's very intimidating. That's true. And Kubeflow can help.
Okay. Yeah. On the other, maybe more tricky side, because you mentioned networking, and I know that at least from my experience deploying a lot of big clusters, this is actually the biggest pain because NVIDIA is making a cool job in making their GPUs super performant and so on. But whenever you start putting them not even in different locations, but in different racks in the server room, and you need to connect them, then the problem starts occurring. So there are different ways how to handle it. There is the Rocky, like RDMA over Converged Ethernet. That's a popular one. There is InfiniBand, which we had for a couple of years coming from HPC world. Now we have Spectrum X, which is dedicated to AI, but these are all very weird networking technologies for like a standard Kubernetes play, and also requires a separate network and so on. So can you tell us a little bit how this looks from your perspective, like additional networking layer and more complexity, how to handle this?
Yeah, it's a mess, to be fair. If I had to be completely honest, I mean, I came from a networking background. So before I joined Spectrocloud, I was at Cisco. So networking is maybe something I was trying to get away from. And you always get back into, it's always the network. That's what we keep saying. Maybe another T-shirt we should make. But I think to your point, there's the side of infrastructure that you really cannot avoid. And I think to Andreas' point, when you're starting things out, you can, hide and move away from it. But as you start scaling and you start to maturing, you can't avoid. And I think that's when you start going into these different networking types. Okay, am I going to use Spectrum X? Am I going to use InfiniBand? Am I going to use something else? Is my network performance enough so that I can avoid these altogether? And I think even from a Kubernetes play, this is all very new, right? And for people that are not so familiar with Kubernetes, like the networking Kubernetes side is actually something that Kubernetes does not take for granted, right? So you actually have to install the CNI or the network interface onto your Kubernetes cluster because it doesn't come included with Kubernetes daemon or whatever you want to call it. So Kubernetes or networking for Kubernetes itself, it's something that is very sensitive, right? And it's something that it cannot be, or typically should not be, abstracted. And obviously you have different flavors, different choices, and that will depend on the underlying infrastructure. Now, I would say that running these specialized AI workloads is almost like running a service provider with Kubernetes, because you have all of these different specialized hardware that you now have to include into your Kubernetes clusters. And there's a bunch of different Kubernetes operators that you can use and install. I think the NVIDIA network operator is one, which abstracts some of this away for you, so you can install the network operator and then play a little bit with it and then use these different super NICs, as they call them. I saw it the other day. It's actually pretty funny. But I think it really depends on the use case. And I think most people, to your point, Maciek, if you're on the 101 path, initially you probably want to run away from this because it's all a little bit of a mess. But as you scale and as you need to service all of these different, let's say, Kubernetes clusters for AI ML training, then obviously your estate starts growing and networking matters, storage matters, and then you have to start looking into those. And I think to your point right now, all of this is still quite new to Kubernetes. I think that NVIDIA, because obviously they have their own, to your point, they have some of their own NICs, they have some of their own protocols. Their network operator is very good. It's not bulletproof, but it's very good. And he abstracts a lot of the concepts away. So for Kubernetes, it makes it easy to use. But any of the components that are outside of that, you kind of need to go deep into the weeds and understand how you can plug all of that into Kubernetes. And I think that's when the conversation around Kubernetes really is, or it needs to be, a platform, right? That your infrastructure team builds and develops, and that your ML engineers and your data scientists consume. Because otherwise, you can't really scale that out. That would be my take.
Okay, thank you for that. I think that what makes it also super difficult is visibility, because now we introduce a lot of these new technologies to Kubernetes. We have our GPUs, we have network operators, new concept, multiple clusters bundled up together. How do we observe all of this? If it's working, if it's not working, what's the problem, how to debug issues, like what's your take on the state of observability in Kubernetes, and how the existing tooling that you guys were using for last couple of years relates to all the new types of hardware. Does it support it out of the box? Are there changes that we needed to make? Like how the observability story looks for AI on Kubernetes from your perspective?
I think it's maturing. I don't think it's out of the box yet. And the reason why I say that is because so at Spectrocloud, we actually build some of the observability tools out of the box for some of our customers. So because we want to abstract that away. So we will provide things like Grafana dashboards and so on and so forth, depending on the different use cases. So answering your question, I don't think it's mature enough to the point that it's out of the box. And the reason is because there's still a lot of components at play here. To your point that we were just discussing earlier, right? The networking, for example, there's still no real standard on what networking and NICs and protocols you should be using for AI and to get the best performance. We'll have an idea of what works and what we should be using, but there's no right answer yet. So I think there's a lot of play there still. So I think because there isn't a curated stack yet, if you may, for AI, I think we're getting there. And in your presentation at KubeCon, I think I would argue that that stack that you've presented is as curated as it gets, especially today, with all these different components. And observability was one of them, right? So I think there's a few things we need to consider. So one is obviously network observability. And then when you talk about networking observability, then you'll have the networking on your infrastructure side, and then you'll have the networking within Kubernetes. So you have to observe these two sides. This is not only one. Then you have the application observability as well. And then obviously you want to make sure things like storage and performance of your flows and pipelines, you have that visibility as well. So I think, obviously, for the people that are not familiar with Kubernetes, Prometheus, Grafana, so these guys have been doing it for a long time. I think they bring most of the out-of-the-box experience. And Grafana dashboards, those are the ones that typically people tend to focus on as an out-of-the-box experience. So I would argue that those today exist, but this will be highly dependent on, obviously, the use case that you have. It's like if you're just starting versus if you're now scaling to hundreds of users on your AI stack. So it really depends. But what, in your perspective, what do you guys see though? Because it'd be interesting for us. Obviously, we hear a lot from the infrastructure teams, but it'd be interesting to understand from your side, what do the ML ops and the ML engineers, the data scientists, what do they want to see when they deploy this at scale, right? Not when they playing in the lab, but when they're deploying at scale. I think it'll be interesting to know as well.
I think that from my perspective, at least what I see from our customers, they are asking for three things. First of all, they need a way to share resources efficiently. And by sharing efficiently, I mean on a couple of layers. So first of all, I want to share within my team. If I'm a group of 5 data scientists, we have some quota allocations, but whenever Jeff is not using his part of quota, I can quickly scale my workloads there and vice versa. So that's easy. But then there is a level between multiple teams. If we are a bigger organization, which might be geographically distributed, and it would make sense that when I'm sleeping and not running any job overnight, the cluster is empty. It would be nice if someone else can use it efficiently and so on. And I can see a nice dashboard telling me like, hey, the Singapore team has some free resources this night. You can jump your training there. And also on the higher level between departments, if there is an imbalance, like one department is always on 95% utilization, the other is on 20, I would like to be able to rebalance the underlying hardware with things like mass resource pools or something like that between the clusters. So that my cluster actually has more resources and the cluster that is almost always underutilized has less resources. So this type of first detecting these situations, then quickly changing the config, or even better, automatically changing the config, that would be like the one area. So basically balancing the resources between the teams. The second area is looking into the why something failed, because this is a new area for us as well, with all the LLM trainings, tunings, all the new ways of doing quantization and track and all the cool things on the ML side. Means that we are using a lot low-level APIs, doing some strange CUDA calls, and things will crash. I want to be able to really, in an efficient way, go to one place to see a timeline and logs from various different places, from the operator, from the driver, from Kates, what actually failed. So that's the second thing that I do mostly in terms of interacting with Kates. And last but not least, whenever the performance is too low of something that I'm doing, like I would expect that if I have a cluster and 10 800 GPUs distributed somewhere, that's more or less the performance I should get, and half of it. I want to be able to trace where is the blocking point so that I can come to your team and annoy you, like why the networking is configured wrongly or whatever. So these are the things that I would want as a data scientist.
I think, Maciek, you're going very far in the journey of a data scientist. You're talking from the perspective of someone who's very experienced, I would say. But if you take a step back, there is obviously, I think, a lot of lack of knowledge. I see a lot of professionals, I see a lot of organizations not even realizing that they underutilize their resources. So I think simplifying it a lot will help. But then also one thing that Maciek also pointed out is, how do you easier debug it? How do you, in case something fails, how do you ensure you know how to fix it as soon as possible is crucial for organizations. And last but not least, I'll highlight once again the lack of education on how can actually Kubernetes can help me with my AI workloads, and how can I ensure that it's a helper, not a blocker, because I need to know all these commands and I have all these capabilities that I don't know how to use. It's something that I also see from the market, especially from organizations and professionals that are not that advanced in the AI journey, as Maciek described. But we also highlighted and touched a bit upon the lack of standards and maybe the things that are not there yet. So now I have a question, Pedro. Where do you think Kubernetes is going to be? And what's the role that it's going to play in terms of AI in the upcoming years? I know it's changing. Everything is changing too fast, but still.
All the time. Yeah, what you say today is outdated in 3 months' time or less. I think there's a few things at play here, and like I said, I think the AI adoption is upticking the move from virtualized workloads into bare metal, and I think Kubernetes as an orchestrator plays or has a big play there. So I think there's, at least we see a big shift there where people want to run all these different workloads. And obviously, if you're not running virtualized workloads anymore, you still need an orchestrator. You're running containers, it makes sense. Kubernetes is your orchestrator. You run everything on bare metal. So that's the uptick that we see. And we've been seeing that for past year and a half or so. And definitely AI, there's other factors, but AI for sure is one of the biggest accelerators for that. I think because of that, because most organizations, and again, I think there's a big difference in what people do in a lab and what people will do at an enterprise level, right? So I think even from an AI perspective, AI maturity will have a big play. So as AI starts to move from the lab into the enterprise world, which we've seen and we are seeing in the past couple of years, it's happening more and more. So I think that you'll have different challenges, and for different challenges, you'll have different answers. And I think people are finding that Kubernetes gives answers to those questions, to those challenges. So things like scalability, portability, the way you build pipelines. I think Kubernetes was built to handle those. So I think moving into the future, if I had to predict, I would say that Kubernetes will be for sure one of the orchestration tools that's going to be widely used for AI. I don't know if it's going to win as the one that people will use, but I think it's a very strong contender. I think people are realizing how powerful it is. To your point, there's a lot of fear in people that are coming into, cold into Kubernetes, into this Kubernetes world, and they're like, oh my God, there's so many things to take care of and worry about. Shameless plug, but I think that's why platform, for example, like Palette helps, right? And others, doesn't have to be Palette, but I think a platform that abstracts some of those Kubernetes concepts is really what people then trying to look for. Because how can I abstract away that complexity so I can increase the adoption level and the speed at which my teams can adopt these different technologies? So I think that's another place. So I think Kubernetes will be brings a lot of answers to all of these challenges. Kubernetes itself also brings its own challenges at scale, and I think that's when a platform really helps bringing all these different pieces together, so that you don't have to worry so much about what's the underlying infrastructure, and you can achieve Magic's biggest dream, which is as an ML scientist or as an ML engineer. I don't care, and I don't want to care about my infrastructure. I just want to deploy my pipelines, and I want to make sure that when I do, they are scheduled in a way that I'm maximizing all of the different resources that I have, regardless if I have 10 clusters or 100, or if I have 100 nodes or 10,000, right, with thousands of GPUs, right? So I think that's where we are going. And I think in the future, I think Kubernetes answers a lot of those. So yeah, answering your question, I think there's, as we spoke before, right? I think the stack is still being curated. Like who's going to win as the batch job scheduler, and who's going to win when it comes to deploying Kubernetes or ML pipelines, right? There's big contenders, but I think there's still a lot of different opinionated stacks out there as well. So I think in the future, the stack will change because it's still getting curated. But I think Kubernetes is definitely going to stay, if I had to say. But I'm here to hear what Maciek thinks as well, from his perspective of the world.
Well, in terms of the orchestrator on the low layer, for sure, Kubernetes will stay with us. What we can even see is a lot of people are migrating their existing HPC environments based on Slurm and all the stuff that was still popular some time ago towards Kubernetes. So I think that this will even further accelerate there, because this is a lot of the same resources consumed by HPC clusters and the AI development. So having them under a common orchestrator is logical to reuse the resources even better and increase the utilization. And as you mentioned, there is no single winner in terms of the entire stack, but there are a lot of top projects in terms of how to schedule things between Kubernetes clusters and scheduler for a single cluster and so on. And I think that the bonus of it is that there are a lot of strong open source tools, which makes it easy to actually mix and match and compose something that makes sense for your use case. But I think that by end of this year, we will have a very good standard approach in terms of at least the low layer, how to manage the resources there. What will change a lot this year is coming up with the new types of hardware, because basically there is Intel, AMD, and other players trying to put in their GPUs into case cluster. This will increase the complexity out of a lot of new things, because you now need to manage not only different types of GPUs from the same vendor, but actually also multiple vendors of the GPUs. And then how do you schedule a workload that needs CUDA if you only have AMD GPUs, and vice versa with ROCm? There will be a lot of fun stuff. And there is also new types of devices completely, with GraphCore and so on, like dedicated ML devices. There are no K8s operators for that yet. for sure there will be, because you need to manage them somehow. So there is like tons of new complexity going in, but at least for a typical data center, I think by end of the year, just by popularity contest, we will see that, okay, everyone is doing this in terms of how to build a K8s cluster for AI.
I think one thing that both of you maybe forgot is the sustainability angle. As machine learning evolves, there is also a need to stop wasting resources and start thinking on how we can make the world a better place and ensure that we're not just melting the ice out there. And I think Kubernetes can play a nice role in terms of optimizing how resources are used. And there are going to be standards and likely regulations on a platform or an orchestrator can help with. And I'm far from being a K8s expert, but that's where I would see it coming or going. And being very mindful of time, getting close to an end, is there anything that you would like to add before we wrap it up? Except that I've understood, Pedro, that you also had a talk at KubeCon that people should watch it out. You only mentioned Maciek's one, not yours.
We had another one, more not so much on the AI side, more on the edge computing side, and it was all about how to deploy 2-node, highly available Kubernetes clusters at the edge, which has to your point, has a sustainability concern, because obviously, with Kubernetes for high availability, you typically need 3 nodes. So we're coming up with a way of or building a new architecture which only uses 2. So at scale, when you have thousands of devices, it makes a difference. So it touches a little bit on your sustainability piece. And I do agree that I think Kubernetes as an orchestrator helps there on rebalancing Kubernetes and other tools like MAS, for example, which allows you to rebalance all of these different workloads. For AI and other workloads, doesn't have to be specifically AI, but obviously we know that AI is such a power-hungry workload. But yeah, I think to your point, I would like to echo that we do see a big uptick in our customers as well, where to your point, they know those standards, those regulations are going to come, and they want to be ahead of it. So I think that's also a big play.
That's good to know. And maybe at the next KubeCon in, I think, Salt Lake, we can talk about AI at the edge and how we reduce the power compute of AI at the edge.
Let's do that.
Sounds like a plan. Thank you for your time. And thank you, Pedro, for joining us. This was Ubuntu AI, and your AI journey stops here for now. We'll meet in 2 weeks with a new episode. In the meantime, you can follow more articles from us on Medium. You can watch the talks that both Maciek and Pedro had at KubeCon. And you can give us feedback with topics that you would like us to approach. See you soon.
Thank you all. Bye.
Thank you. Bye.